What I want to talk to you about today is about about IT in not just the specific sense of software testing, which comes under the purview of NATA, but also the general relevance of IT and testing for NATA's business, because I think IT is something that touches everybody, and hence the title, IT Everywhere. So just to give you a heads up where I'm heading with this, the key things I want to talk about is the pervasiveness of software and the need for software engineering to underpin the role of validation, verification and testing across the ambit of those organisations which are covered by the NATA's remit. So and understand the things we should care about in the IT area and for testing. I should say that there are a lot of. I've made a fairly provocative statement there about software engineering is not widely practiced. It's practiced to a high degree, but at varying levels. There are some very strong niches amongst vendors, for example. I mentioned defence, where there are well-entrenched software engineering practices, but in many areas it's done on a fast and loose process, and so which leads to some interesting issues. So it's not so much about how you develop software. There are many models under which you can do your software engineering, so this is not making any specific reference to those models. But in the end, you need to have something, and you need to have enough so what you're building is fit for purpose. And that's what I want to touch on today. So I'll say again, there's a lot of fine work being done out there. Where I'm heading with this, there's really two implications for the software engineering. One is that in terms of the economics, the total cost of ownership of systems, but also it's relevant for the assurance aspects, particularly as we move into more mission-critical applications for software. So the IT is everywhere. Just to touch on a few things, we have enterprise systems, we have embedded software systems, bespoke applications that we have products which are integrated into overall systems. We have operational technology systems or Internet of Things, which are growing the adoption of which is growing at a very fast rate. An example there, like biomedical devices and things that have been touched on by many of the speakers at this over this two-day conference. And it's also important that we have a lot of national infrastructure or critical infrastructure, for which software is a critical part. So you can sort of see where I'm heading with this, using words like critical and about how we can use, how we need to apply software engineering methods to, including validation, verification, to ensure we get the desired outcomes that we wish. So this is in the customer. Oh, sorry, I just jumped ahead of myself there. The customer perceptions, on the other hand, tend to be people think of software as being free, or it's where we accept the existence of bugs. We accept the concept of good enough software. We are strongly aligned with the models, or a lot of vendors are aligned with the models of the minimum viable product. So speed to market trumps other considerations. And there's valid reasons for that. So I'm not saying that's bad, but you have to look at the context under which. You have to look at the delivery context for the software and what makes sense, and then look at what the appropriate levels, what the appropriate mechanisms for assurance should be for that context. So so again, I say these are not bad things, because we have to move beyond. We tend to be thinking tends to be in the market is dominated by this sort of the web application type model, where it's things constantly improved on a rapid cycle, but they don't necessarily, you're not necessarily worried about the existence of bugs and things that don't quite do what they should do. So the reality in the industry at the moment is that demand for third-party testing is quite low. There's a lot of first-party testing done by vendors. There's an increasing rise in response to the assurance demands I've been speaking about, where there's an increased prevalence of second-party testing. And I can talk about the health market or the e-health market in Australia, or the banking market where you have real-time transactions. That relies on second-party testing to raise the assurance level. But third-party testing is still little practiced, and the demand for accredited third-party testing has been very low, except for certain niches. So just in the standards environment, there is there's a whole range of very good standards in the international arena for software engineering. I've mentioned a few key ones here. I don't want to really talk about them in any detail, but the only point I would make about these standards is that they're process standards. They'll tell you how to do things. They won't tell you what to do. So it leaves it up to you, and not inappropriately, to figure out, how to what you're going to test. So there's an absence of standardised tests. Unlike many areas which are covered by NATA's remit, there's often a strong reliance on standardised tests, and it's about the process of executing those tests accurately. Here we're in quite a different world. So a strong point about the software or the IT market is there's a lot of strong industry standards, and they cover a whole range of things. Enormous intellectual bandwidth and capacity has gone into creating these industry standards, and some very fine work done by open, like the Open Group, the Object Management Group, and certain vendors, like the big vendors, Microsoft, IBM. I'm not singling them out in particular. So there's a whole range of vendors which produce do excellent work in terms of software frameworks, which are part of the answer in themselves. So if you build software around these frameworks, that in itself is an assurance mechanism that should not be overlooked. But look in the regulatory situation is that there's very little legislation around that governs the quality of software. There is consumer legislation, which are relevant to the fitness for purpose of pieces of software. But generally it's driven by a procurement market, and the standards an organisation will apply to its procurement and use of software. But the looming issues here are, as we move, and I'll just expand on this in a minute, as we move into spaces where the assurance becomes much more critical, we've got to look at to see what we have in terms of the current market for assurance is fit for purpose. So this is a little diagram I have. Let's talk to this a little bit about. This is a spectrum we've got between the two green blobs, and on the left we have. The vast majority of software lives in that left-hand end. I call it any old software, right? Which is not too, it sounds a bit negative, but I don't mean that. And there's a huge amount of stuff there that lives in that space. And that's where very fine systems and very useful. Our enterprise systems, enterprise resource planning systems, ERP systems, for example. There's a huge economy that runs there, and it produces good stuff. But this is where and it's governed by, it has depending on who's building the software, who's supplying it. The assurance is done in a way to provide a reasonable commercial result. One thing I'll point out about that left-hand end, there's invariably a person in the loop. So you're presented with a set of results. So whether it's a health system or a banking system or just an enterprise planning system, there is that inherent assurance provided by having a person review the results. And in contrast, And on the right-hand end of the market, we're in a different space, and I'll join the dots up in a minute, but on the right-hand space we have mission-critical software, and it's characterised by, usually characterised by no person in the loop. And I've just given some examples there. The modern aeroplane, the wide-body jet, is in fact unflyable by a pilot alone. So simply the reaction time is not sufficient to deal with the perturbations in the flight posture of the aeroplane. So the medical devices are another good area of concern where the device runs, it does stuff. So you rely on the software in these cases to do the right thing. So clearly there's different assurance requirements on the left than to the right. There's now increasingly stuff. What's challenging for everybody is that we are joining up those dots slowly. So just to pick on a couple of examples there, with if GP practice software is now responsible for submitting or receiving, processing, or sending on medical information, then for example, to the My Health record system nationally, then you care about the accuracy and the validity of that information. So you're starting to things are creeping towards the right as we apply software to a greater range of things. One example there, one day soon we'll be sitting in self-drive cars. I know myself, I care about how the software is working. So another dimension I'll mention here as well as the person in the loop aspect from moving from left to right, there's also the relying party aspect. So who depends on the software's working correctly? If I have an industrial control system sitting inside my factory and I manage to destroy my factory, that's too bad for me. If I'm sitting in a self-drive car autonomous vehicle, then you start to. There are other people involved who depend on the correct operation of the software. So we have to consider the relying party aspects. So it's not just a simple one-dimensional thing that we can, as we move from left to right. But what I find in the market, there is this sort of thinking about the assurance requirements associated with those across that spectrum. That assurance spectrum is not often considered. This is where engineering, software engineering, and lifecycle engineering takes a place, because it's a question of what's fit for purpose. There is. I don't want to dwell on this too much. I just make a couple of points. The feeling in the industry is that software engineering is this heavy process thing, just slows things down. That's wrong. Software engineering is about doing what's fit for purpose. It can be light, it can be heavy. Clearly, if you're building a Apollo 13 mission to the moon, then you care. You're going to do it one way, and if you're building a web app, you'll do it another way. But what software engineering does do is link your specifications to your V&V process, your verification and validation process, and that's the thing I want to focus on here. So how much of that is enough? And the boxes on the right, I just want to mention this. So it's not about the software. People focus on the app. You do need to have have assurance around the app itself, but you also need to assure the platform on which it runs, and you need to assure yourself about the configuration of both. Because one thing we know about software is constantly changing. So you have to really and make sure that you manage those changes so that you maintain your assurance posture over the lifetime of the system. And that's where often we have very much a development focus rather than a sustainment focus, where we maintain the assurance of a product over time. Because things do change and they break, and people experience this. At the left-hand end of the spectrum, you don't care so much, you react. But as you move across the spectrum of assurance, then it starts to matter much more. So the underlying the IT area generally is a lack of standardised tests. So that means the industry runs on risk-based testing. So on the professional judgment to determine what gets tested, how you test it. that's where, when we're accrediting a software lab, that's what you have to put your key focus. How is that risk-based assessment being done in terms of choosing the tests that they run? So in a vendor's case, you should be critically interested in how the vendor is in fact doing that, fulfilling that function. There are niches in standardised testing that quite small niches. I won't dwell on those here because it doesn't really help the main discussion today. I'll just say a couple of words about AI, but to point out, AI is a form of IT. It's part of your IT platform, and it takes a natural part. So the things I'm saying about software and about IT systems generally, AI does fit into that, and the same sort of considerations need to be applied, as well as all the fine points that have been made over this 2-day period. But what I will say that the AI aspect, it's not just a single unified blob. You should think about how it features in your development environment, in its tool set. It features in the applications that you build, and it features in your enterprise systems that you use to run your business. So they're quite different use cases or manifestations of AI you should consider. The same manifestations you should consider for all IT, of which AI is an extension. I want to just talk a couple of minutes just about the implications for test labs. So how does all this apply to the test labs under NATA's purview? So I think it sounds almost trivial to say, but we are all in the IT business. Our businesses all critically depend upon some form of IT. So we have to concern what are those aspects of IT, and how am I assuring the integrity of all those manifestations of the IT, the management systems, the test tools that I use, how I go about assessing verifying the software that is subject to testing. How I perform the risk managements to scope the tests to be done, and the procedural and technical controls that apply to that software. It applies to the IT is relevant to the system definition of the system under test. How I'm drawing an envelope around that system under test to determine that the software aspects are evaluated as part of the overall system testing. Because this is not just about IT in the end. If I have system X, it has an IT component. It's about how I deal with that IT component and cybersecurity. And these comments that applies, I'll say it again, it's a repeat of that sort of the 3 boxes I had. It's not just the app, the software, the functional software itself. It's also the platform, the integrity of the platform or the IT platform in which it runs, and the configuration of all the IT components that together make up the software environment. Next steps. There is considerable expertise in software engineering in the community. What I make an observation is that a lot of the software development comes from what I call the IT side of the shop, of IT people who are, you learn how to program, what have you at university, you build software. The actual engineering aspects tend to be more heavily applied from the OT side of the business, the operational technology side of the business, where the engineers are doing, they're running plant or mines or something, where they tend to be coming more from the places where there are higher requirements for assurance, and they tend to apply therefore stronger software engineering principles or techniques or methodologies to provide the assurance they need. So I guess there's a key message there. Those worlds are moving together. We need to make sure that they come together in a way and start to apply the software engineering methods more generally to deliver on the levels of assurance that we need. This may sound a bit. I guess I've been in the business for some decades, and this sounds an odd thing to say, but we need to have customers willing to pay for good software. People don't have the right mindset, and often the good software costs them at least twice what the number they first thought of. And I know I can say this is a direct experiential thing on my part. That people just want the quick result, and that can lead you astray. And that leads on to that total cost of ownership type argument, because you end up having to redo things. And it's not, in the end, it's not sufficient to say, well, we're agile, so we don't need all that stuff. The same principles still apply. The agile by itself is not the answer. It's a methodology, but it doesn't actually necessarily deliver the assurance result that you need. Tool sets and automation is a key factor in delivering economically the assurance level we want. Education, it's about coalescing the IT world with the software engineering world, so we get a better discipline overall. I'm not bagging IT guys. There's a lot of very clever people, and there's huge numbers of them. but the schools, if I look at the universities, they tend to be distinct, still fairly distinct. Even if I go to my alma mater, University of Queensland, the faculty of ITEE, the IT and the EE still pretty separate. So we need to have that coalescence of skills to produce the good result. And part of this is in Engineering Australia, and this is hot off the press, like Engineering Australia is defining areas of practice, includes a new area of practice for software engineering. So this helps to, helps deliver on the overall industry capability. I'm involved in a couple of their working groups as we speak, and I just make the observation that software engineering as a term is still a relatively new thing for us in Australia. So why do we bother with this? Well, it's getting back to the old saying that back in the early 90s, software quality comes for free. I'm just really using an extension of that saying now to say that the software assurance, it comes for free. If you do the engineering, it pays for itself. So that underlying dynamic has not changed. So in conclusion, we're all in the software business. We have IT in everything. The systems we're testing, we have it in our labs. It's in our laboratory information systems. So we should think about that, our dependence on the software, and how we should include that in our thinking about how we run our businesses, as well as how we test things and what we test. So, and the drivers there are, it's again, from a software point of view, it's a cost of ownership issue, it's the assurance issue. With the added spice here, that as the world is clearly moving towards the use of software and more mission critical systems, and this is the kicker, right? If we're moving to a world where we depend on software, the way with increasing dependence on the way software runs, then we must answer this question. We must provide the assurance mechanisms that give us that deliver ultimately the end user trust in the systems that employ that software. That's the message. So I'll like to conclude at that point. Thank you.
When does validation need to be done?
Yeah, there is a distinct difference between validation and verification. I will say even in the technical literature, the terms get horribly confused. There's a lack of good definition. I think the best definition I've come across over many, many years is that validation is about building the right system, and verification is about building it right. So validation is about making sure that what you're building maps back to requirements. Verification is this is a very important difference. Verification is about the testing that goes with, or it goes with generally the testing that verifies that you've actually built things correctly and it operates correctly. Many people struggle with that one.
Well, please join me to thank David one more time.